Hello, we're looking at the Chapter 3.3 worksheet, Constructing Bootstrap Confidence Intervals. In the last video, we looked at question 1, analyzing textbook prices with a sample of 10. Example 2, we looked at examples of constructing various bootstraps, whether they could be bootstrap or not. And then we finished looking at constructing a confidence interval of what percentage of Americans believe in global warming. And given a bootstrap distribution, we got a standard error, and the center would be the sample proportion of the confidence interval. And we also went over to stat key just so we get the same exact thing. And as a quick review, we found the center, the 95% interval, to be the sample statistic, the p-hat, and then we used the bootstrap distribution to create a standard error. And then for 95%, we're going to double that standard error. And we got that we're 95% confident that the true proportion of all Americans who believe that there's solid evidence of global warming is between 57 and 61%, at least in 2010. So this data is a little bit old. So the same survey also asked political party. So we could ask the same question, not the same question, but does belief in global warming differ by political party? So the same question was asked, is there solid evidence of global warming? And they also asked, you registered Democrat or Republican? And we got that 79% among Democrats and 38% of Republicans said yes, there's solid evidence of global warming. So here I want to note, this one's a little bit more complicated. But the center of the 95% confidence interval is going to be p-hat, I'm going to do subscript D for Democrat minus p-hat subscript R for Republicans. And here we're given, not in the explanation, we're given 79%, but over here we're given group 1 to be 790 out of 1,000 Democrats. Said they said that there's yes, solid evidence to support global warming, and I'm going to subtract that from the 380 out of 1,000 Republicans said yes, there's solid evidence of global warming. So it's 79% minus 38% to get the 0.41. All right. The standard error is the standard deviation of the bootstrap distribution. The standard error is equal to about 0.02. So right here, if we're given a bootstrap distribution, it is the standard deviation. But I want to show you, you could get this yourself on stat key. Go over here to stat key. Now we're looking at example 3 was a single proportion. This problem, we want to move over to a difference of proportion, confidence interval for difference of proportions. Click on Edit Data, and now we have two groups. Group 1. Let's make this a little bit bigger so you can see it better. So Edit Data, Group 1 was the 790 out of 1,000, and Group 2 was 380 out of 1,000. I'm going to click OK. Here we got that 410 difference between the two groups. I want to generate, I like doing at least 2,000. Notice right here it says the standard error is about 0.02. So do you want to note before we go back to the worksheet, we could have switched these groups. In other words, I could have made this 380 out of 1,000 and 790 out of 1,000. Notice the only thing that does over here is it makes the difference between groups negative 0.41 instead of positive. But if I generate a couple thousand samples, the standard error doesn't really change. The standard error for these bootstrap randomizations is not exact. You might get a slightly different number. Oops. This time around I got a 0.021, but that's okay. That's pretty close to the standard error. Generate 1,000. This might go back to 0.020. Like I said, if we reset this and do this again, we might get, there we go, a slightly different number. So it's okay, you're not going to have the exact same standard errors. It might vary, but not by too much. should be about the same for most people in the class as you go through these problems. Now, even though we could switch these two groups, I like to tell my class that it's better to make the larger value the first group. So then you don't have to deal with negative numbers. Negative numbers just can be a little bit confusing interpreting them. Anyway, so for constructing the confidence interval, we're going to take the center. So the 95% confidence interval is 0.41 plus or minus that margin of error, but that's 0.41, which is the sample statistic, difference of proportions, plus or minus 2 times the standard error. So we're going to take 0.41, add, and then subtract 0.04. So here what I did right there is I just doubled my standard error, 2% to make it 4%. So then 95% confidence interval, if I subtract 4, is going to be 41 minus 4 is 0.37. 2, if I add 0.4, it would be 0.45. Okay, that's constructing this confidence interval. So it's 37 to 45%. But now I want to give a interpretation. So what does this number mean? Well, we did the proportion of Democrats that believe in global warming minus the proportion of Republicans. So how I interpret this 41 is from the sample, 41% more. Democrats believe in global warming, 41% more than the Republicans from the sample. So we can say we are 95% confident that the proportion of all Democrats that believe in global warming is between 37% and 45% more than the proportion of all Republicans that believe in global warming. I'll put a parenthetical, at least in 2010. That's when the study was done. So this data is old. These numbers might, hopefully, most likely will be very different right now. But again, the idea of we are 90% confident that the proportion of all Democrats, so I want to refer to the entire population that believe in global warming, is 37, it's between 37 and 45% more than the proportion of all Republicans. So there's kind of a lot to unpack here, just these two numbers. So if I were you, I would kind of write this down on a piece of paper, make sure that makes sense to you.